Okay, so what they're asking us to do on this question, let me roll it on down here. What they're asking us to do is find the quotient and the remainder using long division. So this is not going to be super easy, just to be frank with you. This is not super easy, long division of polynomials. So we're supposed to divide. Notice we have this divided by this. How do we do it? Well, carefully. here's the deal. If we just had, if we didn't have that plus 3, if we just had the 5x. So if there was only, well, let me just put it this way. Dividing by one term is easy. That's easy. Just put that term under each numerator term. That'd be easy. If we just had a 5x there, I would just go 5x cubed divided by 5x. So minus is this. Minus 22x squared divided by 5. So I'm just going to stick this 5x underneath all of them. Plus 5x divided by 5x. Plus 12 divided by 5. So it'd be a piece of cake. I just put that 5x underneath all 4 of those, and then I would just reduce. I would just go 5x, cancels the 5, and this leaves x squared. So it'd just be x squared, and then 5, 5 can't go into 22, but x cancels this, would be 22x over 5. Plus, this would be 1. 5x, 5 is totally canceled. Plus, and then this one can't reduce, and then that's it. We're done. That would be the answer. It would be that easy if we just had 5x down there. That's just one term. This is one term, but what we have is 2 terms. We actually have another term. We have that plus 3. So we have 2 terms. Terms are things separated by pluses and minuses. So we have 2 separate terms. 2 or more terms. 2 or more terms in the denominator requires long division. We have to basically do the dividing more carefully. We have to do long division. So that's what we're going to do down here. Let's do the long division. And I think I'm going to put it on a whole separate page just to make life easier. So I'm going to bring it down here like this. And I'm going to put the, it's the bottom into the top. So the bottom, bring it down a little bit more. There we go. 5x plus 3 into the top. What's the top? 5x cubed minus 22x squared plus 5x. Oops, slopping that up. 5x plus 12. There we go. So you have to do long division. Like it says here, it requires long division when there's 2 or more terms in the denominator. 2 or more terms in the denominator requires long division. If we just had 1 term down there, that would be a piece of cake. I showed that right here, but that's not what we have. Okay, so got to do long division. Now, what do we mean by long division? This is not easy. I know I keep saying it's not easy. Here let's get going. Think back to how you do normal long division. Like, how do I do let me make one up. How do we do 12 into 4, 8, 7. What would we do? We would go 4 times 12 is 48, subtract 0, bring down the 7, right? Remember by hand long division with numbers? Well, it's the same thing with letters. It's just a little more complex, but it's the same basic idea. So notice what we did there. We said 12 goes into 48, didn't we? Okay, same thing here. 5x plus 3, specifically, it's easiest just to look at the very front. 5x goes into 5x cubed how many times, right? We wrote the 4 up here because 4 times 12 made the 48, which matched the 48 that was there. So I could do the same thing here. What can I put up here times 5x that will match 5x to the third? Everybody seeing the question? It's the same thing as you do with normal number long division. 4, why? Because what times 12 will match 48? Well, 4 will. So what times 5x? Just look at the front. Don't worry about the 3 right now. There's too much going on. Just focus on the front and the front. So what times 5x will match 5x to the third? Just like what times 12 will match 48? So what times 5x will match 5x cubed? X squared, right? X squared times 5x will be 5x to the third. Remember, because this invisible 1 power and the 2 power add, but he won't only go there, he'll also go there. Just like the 4 multiplied both the 1 and the 2. 4 times 1 made 4, 4 times 2 made 8, 48. So the x squared goes here and here. So x squared times 3 is plus 3x squared. We good so far? See how the first step is really the same? It's just with letters instead of only numbers. Okay, now what do? Now you need to subtract, right? Like we did here. We drew our line and we subtracted. So draw your line and subtract. But the easy way to subtract a whole bunch of things, because really I'm supposed to subtract this whole line here, aren't I? So the easiest way is just subtract each one. Subtract this guy and subtract that guy. That way you're subtracting the whole line. Just like I did here, I did 4 minus 4 and I did 8 minus 8. We just do it kind of automatically with numbers. But we have to be intentional with letters. So subtract this part and subtract this part. So this is 0. And this is minus 22 minus 3 is what? Minus 25x squared. Everybody see that? Easy chance to make a small mistake right there. So again, what are we doing? We're subtracting this whole line, just like we do with numbers, right? 4 times 12, 48, and then you subtract the whole 48, the 4 and the 8 from what's above. Same thing here, right? We multiplied the x squared times both these, and then we draw our line and subtract both of them from what was originally there. And then minus 22 minus 3 is minus 25x squared. All right. And now what do we do with the 5x and the 12? Well, you know, what do we do with the 7? We brought it down. So bring them down also. Bring their signs down with them. 5 plus 5x plus 12. You can bring them all down at once or one at a time. It doesn't really matter. I'll just bring them all down at once. All right. Now, don't worry about this 0. It's just 0. Let's just get rid of that 0. Okay. Next step. Next step. Like suppose there was more to this problem. Let me just to help. Like what if there had been, I don't know, something else here. What if there had been I don't know, 793, let's say. What would we have done? Brought down the whole 793. And then we would have tried figuring out how many times we can, what we're going to put up here to do the next one. Well, that's exactly what we do here. What we look at is front and front. Don't worry about these guys. Don't worry about this guy. Don't worry about anything else. Just look at front and front and ask yourself, what can I put up here times the front that will match the front? See how it's front, front? Don't worry about this guy. Don't worry about these guys. Just what can I put right here times the front that will match the front? What times 5x exactly matches? Same sign, same everything, identical match. What's it got to be? Well, it's got to be minus 5x, right? Get rid of zeros here. This minus 5x is going to go boom and boom. Minus 5x times plus 5x is minus 25x squared. Perfect match. See that? That's what you want. You want an exact match. Same sign, same everything. And then minus 5x times plus 3 is minus 15x. So whatever you write up here, you multiply both those and write them down here. That's what we always do with long division. Everybody tracking with me so far? Questions so far? Making sense? Whatever we write right here, minus 5 goes there, and we write the answers there and there. Now what do? You watch this. This can trick people. You draw your line and you subtract. But they're already negative. See how this guy is already negative and this guy is already negative, and I need to subtract. So that means cross this out, it's going to become plus. Cross this out, it's going to become plus. Why? Because I subtracted the whole line and it distributed in. It just gets too messy. I don't want to write all that parentheses. So I subtract all. Same thing I did here. I subtract all, right? That's what we do. When we, after we multiply, we have to subtract. And if the things are already negative, well, then when you subtract a negative, it becomes positive. So see how they both became positive, actually? You see that? And it's a good thing, isn't it? Because now minus 25x squared and plus 25x squared makes 0. And that's what you want. You want that 0 in the front. And what happens here? Plus 5x and plus 15x is plus 20x, and then just bring down plus 12. We have one more step to go. Is that good to there? So you're, again, after you multiply, you subtract the whole line, which means you change all the signs. Okay, erase this monkey business. Put this up here again. Okay, we have one more to go. Where do we look? Let's get rid of this 0. We don't need that 0 anymore. You know where we look. We look at front and front. Forget about that. Forget about that. What am I going to put up here? Times the front that will match the front. What times 5x exactly matches, same sign, same everything, plus 20x. What times 5x makes plus 20x? Plus 4. That plus 4 goes there, and that plus 4 goes there. And you write the answers there. Too far there. So plus 4 times 5 is plus 20. And then plus 4 times 3 is plus 12. Beautiful. That's an exact match. It's perfect. You know what to do, right? Draw your line, subtract all, which means get rid of that, change to minus, get rid of that, change to minus, 0, 0, right? 20x minus 20x, 12 minus 12, 0, 0. So that's 0, 0 remainder. So if we had a number here other than 0, then that would be our remainder. We happen to get a 0 remainder. So then our answer is, how does it happen? Well, on the thing, they have the quotient and they have the remainder. So let me write those for us. Put it up here where we have room. So the quotient is, the quotient is the x squared minus 5x plus 4, and the remainder is 0. Now yours will probably have a remainder other than 0, but ours came out with a remainder of 0. The quotient is the top of the part, right? Is the part at the top. That was funny. The part at the top is the quotient, and the remainder is the last leftover amount, just like when we divide with numbers. And there we go. We long divided that. In other words, we basically found out when 5x plus 3 goes into 5x cubed minus 22x squared plus 5x plus 12, it goes in this many times, meaning this times that equals this. That's how many times 5x plus 3 goes into that 5x cubed thing. It goes in x squared minus 5x plus 4 times, meaning if you divide these, you divide this fraction, the answer is this quotient with no remainder. There we go. Questions on that one? Questions I can answer. Questions I may not be able to answer. Any questions?